So lesson one is talking about properties of parallel line. Okay. Can you hear the music? Can you hear the music?
Yes, we can hear it.
Okay.
Welcome to Math is Fundamental. Today we're going to talk about some angle properties using parallel lines and converses. So let's get started. We have, in the last lesson, we learned about all these different types of angles, corresponding angles, alternate interior angles, inside and exterior. And we defined all of those, but today we're going to take it one step further and learn some theorems about those types of angles. So each one of these theorems, and I'll read through all of them, but each one of these theorems requires parallel lines. It does not work if the lines aren't parallel. So keep that in mind. All right, first one, we have corresponding angle theorem, which says if two parallel lines are cut by a transversal, then corresponding angles are congruent. So for example, if I have angle 1 and angle 5 here, then I can conclude that angle 1 is congruent to angle 5 because they are corresponding angles. Next one is alternate interior angle theorem, which states if two have to have parallel lines are cut by a transversal, then alternate interior angles are congruent. Again, so let's look. Alternate interior angles, let's look at angle 3 and angle 5. So alternate interior angles 3 and 5. If we look at the sides of those angles on the diagram, they both look obtuse, as opposed to both being acute or one being obtuse and acute. Kind of look at the sizes if you don't remember exactly what the theorem says. So here we have angle 3 is congruent to angle 5 because of the alternate interior angle theorem. All right, next, alternate exterior angle theorems. Let's look at a couple alternate exterior angles. Let's look at angle 1 and angle 7. Now, look at the sizes of the angles. They both look obtuse again. You know, we could change it up and we could do angle 2 and angle 8. Both of those are, again, alternate exterior angles, but this time they're both acute. Either way, it looks like they're going to be congruent. And it turns out the theorem states if two parallel lines are cut by transversal, alternate exterior angles are in fact congruent. All right, now, last one. Same side interior angle theorem. So again, could be consecutive angle theorem, but I usually use same side interior angle theorem. All right, says if two parallel lines are cut by a transversal, then same side interior angles are, well, let's look at some same side interior angles. Let's look at angle 3 and angle 6. Look at the sizes of those angles. Angle 3 is obtuse and angle 6 is acute. Are they going to be congruent? Probably not. So our other option here is that they end up being supplementary. So angle 3 and angle 6 are supplementary. And that's our same side interior angle theorem.
Okay. So do you have any question? So we have a corresponding angle theorem. So if two parallel lines are cut by transversal, then corresponding angle are congruent. So this one is so this is corresponding angle. So this one and this one. Also this one and this one. Right? What else? I'm saying this one and this one. Right? And then this one and this one. Okay. So all of this is we call it the corresponding angle. And they are congruent. So remember this. And the next one, call it the alternate interior angle. So alternate angle theorem is this one, and also this one and this one. Okay. I think that's it, right? And the next one is alternate exterior angle. So it will this and this. So this one and this one.
Or one being obtuse and acute.
So yeah, alternate exterior will be this one. Yeah, so this one and also
Now, look at the sizes of the angles. They both look obtuse again. You know, we could change it up and we could do angle 2 and angle 8.
yeah, so it's
Both of
only
those
two.
are,
Okay.
again,
This one and this one
alternate
and this one and this one.
exterior
So we call
angles,
it
but this time
alternate
they're both
exterior
acute.
angle.
Either way, it looks like they're going to be congruent. And it turns out the theorem states if two parallel lines are cut by conversal, alternate exterior angles are in fact congruent. All right, now, last one. Same side interior angles and
Yeah, so
angle 6. Look at this 3. We're given
that's all.
that line accurate? Probably not. So our other option.
So this will be this one and this one supplementary, and this one is supplementary. So we call it same side interior angle theorem. So I think the next problem, the next one will be proving that this two line is parallel. So I mean, if you have a two line parallel, and then you need to prove angle 1 and angle 8. Okay, so you need to do like this one. So to prove it, you need to use this step here. So first is a parallel line A and B, right? It's given. Okay, and then A1, because it's what I think alternate exterior angles, right? So this sorry, this is corresponding angle theorem. So angle 1, measure angle 1 is same as measuring angle 5. I mean congruent. So that means the same measure. Because it's congruent, so then it's the same. It's in the difference of congruent angles. So now angle 5 plus angle 8 is 180 degrees. Right? Okay. So we can using the linear pair postulate. Remember from the last chapter. And then next step will be and also angle 1 plus angle 8 is also 180 degrees. Yeah, so angle 1 plus angle 8 is also 180 degrees. Because this is our supplementary, right? And then for this one, if you add this angle with this angle, I think this on the, yeah, so you can see the separation here. We call it a substitution property. Yeah. So you replace angle 5 with angle 1 because they are congruent. Right? So the summation will be the same. Okay, so now because 1 and 8 is supplementary, so the conclusion will be yeah. So yeah, just to prove that supplementary, right? Because if you add this to 180 degrees, so the conclusion will be angle 1 and angle 8 is supplementary. Yeah, so this for lesson 1, okay. So lesson 1 has how many topic, how many concept that you remember? That we need to write and answer. There are 1, 2, 3, 4, 4 topics, 4 concepts. This is the answer that you need to put in the in your answer. So this is the property, and you need to give the example for each property. I mean, definition. The property and the definition, and then you need to give the example. So this for lesson 1. Okay. Any question?
Hi class, welcome to Math is Fundamental. Today we are going to be talking about how to prove that lines are parallel. In the last lesson, we learned about different theorems using parallel lines and transversals, like corresponding angles theorem, alternate interior angles theorem, and so on. Today what we're going to do is look at the converse of those theorems. Now remember, converse is when you take a conditional statement and switch the hypothesis and the conclusion. So the first piece and the last piece will just switch places. That's what we're going to be kind of looking at today. So starting off, the converse of the corresponding angles theorem states that if two lines are cut by a transversal and corresponding angles are congruent, so you have to be given that piece of information, then we can conclude that the lines are parallel. So a little bit different this time. In the corresponding angles theorem, we were given the lines were congruent and proving that corresponding angles we're given the lines are parallel and proving that corresponding angles are congruent. Now, we're given that corresponding angles are congruent and we cannot prove that the lines are parallel. So, for example, if I was given that angle 1 was congruent to angle 7, those little lines, this little arc marks mean that they're congruent. So if I have angle 1 is congruent to angle 7, then I can state that A is parallel to B using the converse of the corresponding angles theorem. Right. Similarly, let's look at the rest of the theorem. We have the converse of the alternate interior angles theorem. It states that if two lines are cut by a transversal and alternate interior angles are congruent, then the lines again are parallel. So let's look at alternate interior angles. So let's look at angle 3 converse of alternate exterior angle theorem. All right, let's look at two exterior angles. Let's look at 2 and 8. So if I have two lines, A and B, cut by transversal, and alternate exterior angles are congruent. Oops, I forgot to mark my angles congruent in the last example. So let's mark those two angles congruent, 3 and 5. And in this example, let's mark those angles congruent, 2 and 8. All right, so then I can say that the lines, again, are parallel. So if angle 2 is congruent to angle 8, then A is parallel to B. And last one, converse of the same side interior angle theorem states that if two lines are cut by transversal and same side interior angles are supplementary, then the lines again are parallel. So same side interior angles, let's look at angle 4 and angle 5 here. Those two angles are on the same side in the interior of the lines. Now they're not congruent, but if I know that angle 4 and angle 5 are supplementary, then I can state that A is parallel to B using the converse of the same side interior angle theorem.
Okay, so yeah, so then the for lesson 2 is talking about the converse of the theorem in lesson 1. Okay, so like if you have a same side interior angle congruent, so the line will be parallel. Okay, let me see what is the next one. Yeah, so the next one is talking about the problem here. So looking for what is the value of I think it's with W that would make the two line parallel. So this is, so we can use the alternate exterior angle, right? So this angle equal to this angle, so you can solve the problem. I think the answer should be right. If this equal to this, so add both side with 2, so we get 57 here. And on the left side you got 3 W, right? So W equal to 55, sorry, 57 over 3. So she tried to make it become the yeah, if you divide 57 over if you divide 57 with 3, you got 19. So what is next one here? The next one is given this equal to this, right? Now you need to prove this this line is parallel. So to prove it, let's see. Yeah, to prove it using the converse of the alternate exterior angle theorem. That is this angle and this angle as alternate angles. So we know that this angle 1 and angle 7 given they are congruent. Okay. Angle 1 congruent with angle 3 because they are vertical angle, right? Okay. And angle 3 and angle Yeah, because angle 1 is congruent with angle 7, and then angle 1 congruent with angle 3, so angle 3 congruent with angle 7. So angle 3 congruent with angle 7. And using the alternate angle theorem, we can prove that the line A and B are parallel. Any question? So you can see it over there. Yeah, so this is lesson 3. Okay. Sorry, lesson 3. Lesson 2. Okay. Lesson 3. Talking about parallel and perpendicular line. Okay.
Hi class, welcome to Math is Fundamental. Today we're going to talk about parallel and perpendicular lines, a couple new theorems. First one, now there's no names to these theorems, so if we use them in a proof, you're just going to have to kind of briefly explain what the theorem says. You can use, short abbreviations and symbols and things, but no names. All right, the first one says, if two lines are parallel to the same line, then they are parallel to each other. So, a little diagram to help us out. If we have P, Q, and R, so 3 lines, P, Q, and R. If P is parallel to Q, and R is parallel to Q, then P has to be parallel to R. So symbolically, what that looks like is if P is parallel to Q and R is parallel to Q, then P is going to be parallel to R. So that's what that theorem states. Next one says in a plane, so it has to be all coplanar lines. If two lines are perpendicular to the same line, then they're parallel to each other. So let's just use P, Q, and R again. So slightly different setup. And Q. All right, so if two lines, so we have P and Q, and they're both perpendicular to R. So if P is perpendicular to R, and Q is perpendicular to R. If P is perpendicular to R, and Q is perpendicular to R, then we know that P has to be parallel to Q. And if we look at the diagram and we draw these diagrams carefully, these theorems, even though they look long and lengthy and you have to explain them in the proof, they're not that bad. They're pretty self-explanatory when you have a good diagram. Right, last one. In a plane, if a line is perpendicular to one of 2 parallel lines, then it's also perpendicular to the other. So what we have here is slightly different than the last one, looks kind of the same, but this time our given information is that one line is perpendicular to one of 2 parallel lines. So if R is perpendicular to P and P is parallel to Q, so that's our setup here. So if is perpendicular to R and is parallel to Q, then, well, what can we say about Q and R? Well, Q and R have to be perpendicular. Q is perpendicular to R. All right, so let's look at a couple examples here, and use the.
Okay, so yeah, you can see here. So if P parallel to Q and then Q parallel to R, and then P parallel to R. If P parallel, perpendicular to R, and then Q perpendicular to R, the conclusion is P parallel to Q. And the last one is if P perpendicular to R, and then P parallel to Q, then the conclusion is C product berkuasa. And this is some example here. So in this case, A parallel to B, and then B parallel to C, and then C parallel to D. So, and then tell how A and B are related. Okay. So what is that? I think A to D is A parallel to D. Now, if the A perpendicular to B, and then B perpendicular to C, and then C parallel to D, then the conclusion will be A perpendicular to D. Yes. Here. So A perpendicular to B, and then B parallel to C, and then C parallel to D. So the conclusion will be A perpendicular to D. Using one of this, using one of the property. Okay.